A very good morning, one and all. On behalf of the trustees, management, principal, HODs, staff, and students of SA Engineering College, I extend a warm welcome to one and all present in this virtual platform. To know more about our college, SA Engineering College was established in the year 1998 and is successfully continuing its educational service beyond 25 years of excellence. SA Engineering College has taken the forefront of technical education through its distinctively different and carefully nurtured standards. The college is approved by the AICT New Delhi and affiliated to Anna University, accredited by the NBA, and also has an A grade from the NAC, and also is an ISO 9001-2015 certified institution. The Department of ECE believes in preparation for the life ahead in all earnest and provides every opportunity to grow beyond academics. In view of the same, many in-house programs like placement trainings, value-added courses, workshops, conferences, symposiums, and guest lectures are also organized to make the students industry ready. We all have gathered here to motivate and cherish the young minds present among us. At this juncture, I take immense pleasure in welcoming Ms. T. Keerthana, Master Trainer Vedantu Private Limited, for the Tech Series 4.2 to deliver a talk on emerging trends in nanotechnology. We welcome you, ma'am.
Man. So it's truly an honor to be here with you all today. Hope you all guys doing well. So students, I would like to ask the question, right? So how would your exams? How you wrote your board exams? Yes. So I need some thumbs ups in the live chat. So today we are going to learn a huge knowledgeable concept that is nothing but nanotechnology. Can we start the session? Yes, so I'm going to present the screen. So before going to the session, I would like to ask some questions. Can I? Yes, so can you imagine a world where clothing is a self-cleaning? So it's nowadays many people are behaving like a lazy one, but it will be a more advantage one when our clothes will clean its clothes selfly. It will be good, but it only being capable doing through nanotechnology. Yes, so can you drink seawater? So today's water crisis means a lot. In every cities, water crisis plays a major role. There is no lot of water, so we need rain water. We need to plant tree to get that rain water, but none of them do that. Yes, yes. So we can able to convert the seawater into pure water through amazing technology that is nothing but nanotechnology. Yes. So one more question. So what is nanotechnology? Can anyone guess? So what is technology? Yes, technology is nothing but a scientific invention or scientific innovation that will help our practical life. Yes, so through this nanotechnology, we can able to develop our practical life into an innovative life. Yes, so today we are going to learn about nanotechnology. Yes, this nanotechnology is nothing but we can able to do a huge product into a nano size particle. Yes, super. Nanotechnology is a technology about small things. Yes, right. So nanotechnology is we can able to manipulate a small thing to get a large thing. So we can able to provide electrical properties through this nanoparticles. Yes, where will this nanoparticles will get? Where should we get this nanoparticles? Yes, where we should get the nanomaterials? Any ideas? So what's the major size of nanomaterials? So what will be the size? Any guesses? Or otherwise cannot tell? Yes, so we can able to get this nanomaterials and nanoparticles in our world. The range of this nanomaterials is 1 to 100 nanometer. The sizes are human hair. So human hair, in the deep of human hair, we can able to measured. So 1 to 100 nanometer is the major range of these nanoparticles. Yes, super small in size, then super it will helpful in our healthcare. It will helpful for our industries. We can able to produce many kind of pencils, graphings like that. Yes, so nanotechnology was developed by Richard Feynman. So he wrote a journal regarding yes a small plenty of room at the bottom. So what is plenty of room? We know about cells. What is cell? Yes, from atom we can able to produce a molecule. Yes, so group of atoms can be say as molecules. Then what is group of molecules? So with the group of molecules, what we will make? Any guesses? Can I give any options for that? So organelles or macroorganelles or microorganelles. So what will be the right answer? No objects, no. So from the group of molecules, what we can make? Microorganelles or macroorganelles or organelles? Yes, super. Macroorganelles. So macroorganelles like mitochondria, nucleus, cytoplasm, lysosomes. Super. Yes, these are the macroorganelles. These macroorganelles are present inside the cell. So from the group of cells, we can able to produce super mitochondria. Yes. So which is the powerhouse of the cell. So which will provide ATP. So this ATP will give energy to walk, give energy to speak, give energy to sing. Yes, right? So from the group of cells, what we can make is a quick response. From the group of cells, what we can make? Yes, powerhouse of the body are mitochondria, right? Yes, from the group of cells, we can able to make tissues. We can able to form tissues. We have lot of tissues like muscle tissues, blood tissues, neuron tissues. Yes, right? So from the group of tissues, organ will form. So organ in the sense, what are the organs in our body? Heart, yes. Lungs, yes. Stomach. Then a super memorable organ. Brain, super. Organ, super. Yes, which will give memory sense. Our brain. So the kidney, yes, super. So these are kinds of organs which is present in our body. Yes, hand. So hand is not an organ. Okay. Yes. So leg. So these organs are formed from the group of tissues. Yes. So from the group of organs, we are a group of organisms. Like we are the peoples. From the peoples only, we can able to develop nanotechnology, neurotechnology, n number of technologies are there. So this nanotechnology, which is macro size, that is 1 to 100 nanometer size, will cure our cancer. This is right. So where the cancer will get formed, where the cancer will affect in our body. So there are n kind of cancers. Blood cancers are there, muscle cancers are there, lung cancers are there, heart cancer are there. Yes, n number of cancers are there. Yes, mostly bone marrow super. So we is this any way to cure this cancer? Is this any way to detect the cancer? Brain cancer super. Yes, the only way to cure this kind of cancers is nanotechnology. Yes, from this nanotechnology, we can able to insert a tiny product that is nanoparticle into the blood, and we can able to detect the cancer. So after that, we can able to cure this cancer. So this is a plenty of room at the bottom. So this kind of nanotechnology was invented by Richard Feynman. So the plenty of room in the sense there is a lot of rooms in our house. So each room contains a major particle. Yes, each room plays a vital role in our house. Like this, in our body, n number of rooms are there. So each rooms provide energy like ATP, like NADPH, but this energies are can't able to produce if there is any defects. If there is any cancers, we can't able to produce energy from that rooms, right? So from this, we can able to overcome this type of crisis from nanotechnology. Yes, so nanotechnology is nothing but which will provide electrical properties from the nanoparticles. There are two kinds of nanoparticles, that is top down and bottom up. So we can be able to learn, we will learn this in further slides. Okay, so what is electrical properties? Yes, what is electrical properties? Any guesses? This is a nanoparticle. So what is nanoparticle? A combination of carbon. Yes, so from the combination of carbon, we can able to get electrical properties. Yes, so from this, the carbon will act as a electrical particle in this nano material. So these kind of electrical properties can be used in a nanotechnology, right? Yes, where we can able to get this carbon from a tiny particle. So from that we can able to get the energy. So from the electrical properties we can able to manipulate the carbon nanotubes, which is called as graphene. We can able to learn in further slides. Yes, so materials have unique number of potentials, unique number of properties. So the nanomaterials which will exhibit extraordinary chemical reactions, biological reactions, physical reactions because it is a tiny object. It is a tiny size. It is a small size with a range of 1 to 100 nanometer. It has a huge surface areas. It also provides effects, that is quantum effects. So this quantum effects will provide through tiny products. So these are the unique properties of nano material. Can I go through again? So from this nanomaterial, we can able to get unique properties like physical properties, chemical properties, then biological properties because it is a tiny size. So then moving to the diverse application. From the nanotechnology, we can get n number of applications. So already we learned in previous slides, that is from healthcare we can able to use this nanotechnology. In industries we can able to use this nanotechnology because this nanotechnology will provide electrical properties. It will provide energy storage mechanism. So where we can store medicines, where we can store the medicine properties, drug properties. So from this application, from this nanotechnology, we will produce n number of products. So nanomaterials are revolutionizing a wide range of industries with their versatile capabilities. What is versatile capabilities? Need answer from your side? Yes, it is useful in IT. Yes, from information technology, we can use this nanotechnology to detect the programming effects. Yes, then there is a rapid advancement in this nanotechnology. Yes, super. Is it? It is useful for doctors to detect the drug, to detect the cancer, to detect the effects. Yes, so there is a rapid advancement in this nanomaterial. So the nanoscale will synthesize the nanoparticles. The nanoscale will synthesize the nanoparticles, and it also characterize the nanoparticles, and it also manipulate the technology. It also manipulates the technical events in the nanomaterials. So it also propel the field of nanomaterials to looking forward for a better output from the nanotechnology. So these are the rapid advancements. There is a huge mm, advantage in this nanomaterials. So moving to the future potential from the nanomaterials, there is a rapid development of nanomaterials which will create innovative ideas, which will create innovative transformative from, sorry, in the field of healthcare, in the field of sustainability, and in the field of cloud computing. So we can able to use these nanomaterials in cloud computing field also. So can we move to next slide? Yes. So these are the minute tiny objects which is present in our body as well as in our external environment. So our blood cells, which is a tiny one, it's just 1,000 nanometer. It's just 1,000 nanometer. But our nanomaterials range is 1 to 100 nanometer. This blood cell is large one compared to this nanomaterials. Then comparing with molecules. What is molecules? A group of atom is called as molecules, right? So we can able to pair four kind of molecules which is very less than 1 nanometer wide. So we can able to compare these nanoparticles with four pairs of molecules. So molecules is nothing but a group of atoms. So here there is a human hair. You can able to see that human hair, so which is present in left hand side of the nail. So this human hair is not a normal human hair. One, when we cut the human hair, that means our external period of human hair, we have to cut the human hair deep. Then we can able to get a tiny human hair that is under 1,000 nanometers thick. Under 1,000 nanometer thick. Then imagine how tiny the nanometer. Yes, our human nails also grow per second as 1 nanometer. So we can't able to see this from our natural eye, but after certain days, after 1 or 2 days, we can see the growth of the nails. Then compared to the earth, the tennis ball. Compared with the earth, the tennis ball is just a 1 nanometer size. Just imagine how the range of the nanomaterial. Can you get this? Yes. So nanomaterials and the drug delivery. Yes, from the nanomaterial we learned that we can able to detect the cancer. Right. So we can able to inject the nanoparticles in the body, and we can able to detect the cancers which affects our body, and we can able to cure it. So the targeted drug delivery from the nanomedicines is the nanoparticles which will engineer to target the specific cells like blood cells, like bones, muscle cells. Yes, we can target the specific cells or tissues to improve the efficiency, to improve the efficiency, and to reduce the side effects of the drugs. So, what will be the bioavailability of this nanomaterials? What will be the bioavailability of this nanomedicine? So, our nanotechnology will allow the drugs to encapsulate. The nanotechnology will allow the drugs to encapsulate to improve the solubility in the cell, to improve the solubility in the tissues, to improve the stability in the tissues, and to observe the cancered particles. It will observe the virus particles which is present in our body. So these are the bioavailability of this nanomedicine. Yes, moving to the controlled release of nanomaterials. These nanomaterials are particularly designed to release the drugs. It is particularly designed to release the drug to control the rate of the drugs. If we inject a large amount of drugs in the body, then what will be the result? So that will be the result, right? So we have to control, we have to measure the rate of the drug. Okay, so the nanomaterials are particularly designed to release the drug at a controlled rate. It also ensures the therapeutical levels. It also ensures the therapeutic levels to optimal uses of these drugs. So these are the nanomedicine and the drug delivery methodology. Can you able to get this? Yes. So moving to the types of nanomedicines. So in previous slides, I thought that it has two types. The nanomaterials are classified into two types based on the structure delivery. Based on the structure delivery. Yes, the one is top-down apparatus, top-down approach. Sorry. So one is top-down approach, and another one is bottom-up approach. So what is top-down approach and what is bottom-up approach? Any ideas regarding this? Yes, top-down approach is nothing but from a large particle we can able to get a small particles. So we have to break into tiny small particles. So from the side you can able to see that from a large size rock we can able to break this and we can able to get the tiny products. You can also see this in our everyday life. So moving to bottom-up approach. So this bottom-up approach will combine the tiny particles into a large one. So the bottom-up approach is nothing but it will combine a large particles into a large one. Sorry, combine a small particles into a large one. So from a tiny product sand. So we know that sand, slit and clay. So sand and slit are tiny one compared to a clay, right? So from the slit, from the sand, we can able to combine and get a large structured sculpture. So this is the great examples for the nanoscale structures. So this is the great example for the top down and bottom up approach. So top down is nothing but from a large particle we have to break down into a small particles, and moving to bottom up from a small particles we have to combine into a large particles. Able to get any doubts? Can we move to next slide? Yes, so the major particles which is present in this nano materials is nothing but graphene. As graphene is nothing but a sheet, a paper sheet like structure. So from this graphene, we can able to develop more innovative ideas. We can able to develop more innovative ideas. We can able to build a house. We can able to build a bridge. We can also able to move to the universe. Yes, so without the help of rocket, we can able to go to the moon from this graphene. Yes, we all know that who is this again billionaire in our world? Elon Musk. So who is the CEO of Tesla? He also undergoing a project through this nanotechnology, through this graphene. So he is planning to make a chip. He also planning to insert the chip in the monkey's brain. So the monkey's brain will the monk in previous days, past 1 or 2 months, the monkeys played a game. So it wants to move, but it doesn't move. It's just thought that it wants to move. So from the chip, the chip detects the monkey's ideas and it automatically undergoes the movement of monkey's thought. Yes, so many kind of people say that this nanotechnology is disadvantage to the human life, but there is a huge advantage in this nanotechnology. So we have to use this nanotechnology in a right way. So this is the graphene sheet. So from the graphene sheet, we also able to produce n number of innovative products which is helpful for our human life, which is helpful for our external environment. Yes, so from the previous slide, I asked you a question, right? So can we produce a self-cleaning cloth? Yes, it is possible. We can able to produce, we can able to manufacture a self-cleaning cloths. So that self-cleaning cloth will be made up of graphene sheet. So this graphene sheet will clean the dust particles. So we all saw Iron Man's dress, right? It's like a iron dress, but which is not an iron dress. It's a nano material graphene sheets iron dress. Okay, so this iron sheet will protect from a gun's bullet. So it will manufacture in the way of bulletproof jackets. So from the graphene sheet, we also able to purify the salty ocean water, salty sea water. So from the graphene sheet, we also able to filter, purify the dust air which is excrete from the industries. Right? So there are huge applications, huge advantages in the graphene sheet. So if you want to develop any innovative ideas in this nanotechnology, kindly use these graphene structures. Yes, so moving to the advantages of the nanoelectronics. So far we learned about these nanoparticles, nanomedicines, nano drugs. So moving to nanoelectronics, which is helpful for the electronics and communication engineering. So there are n number of electronic products like microcontroller, transistors, diodes, etc. So we know that quantum dot transistors. So this quantum dot transistors is made up of nano electronics. It is used to operate nanoscale tiny products, nanoscale tiny electronic devices to enable it faster operation and to enable it to get more energy efficient electronic device. So this is only capable for nanoelectronics products, that is nothing but quantum dot transistors. So moving to this carbon nanotube circuit, which is shortly known as CNT. So this carbon nanotube circuits have a unique properties to create innovative circuits, to create innovative nanoelectronical circuits to get more energy efficient one, which is fully based on silicon designs. So we can able to create power efficiency circuit, that means chip. It also used to reduce the time delay. It also increases the energy efficiency. It also reduces the power consumption in the chip. So these all satisfied through this nanoelectronics methodology. Then moving to molecular electronics, yes, the molecular electronics have a great advantages which will pave the way for future development of molecular scale electronics components. So there are many openings for the freshers in this nanoelectronic field, many openings for the freshers in cloud computing field, which is based on nanotechnology. Yes, so moving to next slide. This nanotechnology have huge storage which stores the energy. Yes, there are a number of energies like hydro energy is there, solar energy is there, electrical energy is there, chemical energy is there. Yes, but nanotechnology will get energy from a tiny products. Yes, there is a carbon molecules which is present in the graphene sheet or which is present in the nanoparticles. They produce electrical properties which is more efficient, which is long lasting batteries, and also it has supercapacitors. Yes, it also behaves as a amplifiers which reduces the signals. So these nanomaterials have a unique properties. It also improves the energy density and charge discharge rates, and it also useful for the energy storage devices. So the nanotechnology paves the way to reproduce, that means recycle a product. So there is no wastage from this nanoparticles. So even a tiny products also useful for the energy storage devices. So from this nanoscale electrodes, we also make nanostructured electrolytes. From a nanoscale electrodes, we also make nanostructured electrolytes. So these also paves an innovative way to be to a portable electronic devices. So there are n number of EV vehicles, that means electrical vehicles, or manufactured in several companies. So these kind of EV, that means electrical vehicles, have nanotechnological engineers. So it also paves engineers, that means nanotechnological engineers, to be a part of this electrical vehicle manufacturing company. Yes, it also useful for renewable energy sources. There are, yeah, two types of energy storage applications. So the one which paves the way and which plays a vital role in our environment is renewable energy source. So from the energy source, we also able to renew the solar energy, hydro energy, and kind of energies. So moving to nanoscale sensors. So already thought that Elon Musk inserted chip in his monkey's brain. As like that, there is a sensor of devices which is manufactured through nanoscales, which has a unique properties at that atomic and molecular scales. Yes, so these sensors have the capability of producing precision control rate, have the capability for novel functionality. In these sensors are miniature products, so it has a tiny products, so it can also able to change within a minute, and it also responds within a minute. So rapid response are there from this nanoscale sensors and devices. So these nanoscale sensors will also helpful for this environmental monitoring, climate conditional monitoring, healthcare monitoring, then solar system monitoring in rockets or satellites. And it also paves a way to track the pollutions, that means air pollutions or soil pollutions. And also it also useful for the delivery of drugs in our body. Yes, moving to the next slide. So Nanotechnology also paves a way for environmental applications. So these nanomaterials filters the water. As I said in the early slides, so can we drink seawater? Yes, we can able to drink the seawater from the use of nanotechnology. Yes, this nanotechnology has a carbon molecules which is present in this graphene sheet. It it lifts the huge weight within a pencil lid. It lifts a huge weight within a pencil lid because the pencil lid in the lid has a graphene material. So this graphene materials is useful to lift a huge weight. So the nanomaterials so enables highly efficient water filtration. So this ocean water contains huge salty substance. So it filters the salty substance, it filters the drainage particles. So from this we can able to get a pure water. So it purifies, it filters, it also removes the contaminants like amoeba, algae like this, bacteria, virus, it removes the contaminants through the advancement of nano scale membranes which is present in these nanomaterials. Yes, moving to air pollution remediation. Yes, we can also able to filter the air pollution which is excreted from the industries with the help of this nanotechnology. So this nanotechnologies neutralize the airborne pollutants excrete from the food industries or any kind of industries. Also create more efficient and suitable solution for cleaner air. That means purified air. So moving to environmental remediations, this nanoscale catalyzed and observes to break down and remove hazardous substance from contaminated soil and groundwater. From the contaminated soil and groundwater. So we can able to purify the soil too. We can able to purify the biocatalyst which acts as enzymes. It also removes the hazardous materials present in this catalyst. So moving to ocean cleanup. Under the ocean, n number of amoebas, n number of bacteria are present. So that bacteria or viruses will affect the ocean plants. So from the nanotechnology, we can able to manufacture a nano robots. So we have to launch these nano robots into deep into the ocean. So it efficiently collecting the plastic materials which is present deep inside the oceans. So it will remove it and prevent from the pollution which is from the world's ocean side. So these are the environmental applications which will pave a way to undergo a better world. So then there are many kind of safety concerns. So the nanomaterials is also provide unintentional effects to the human health. So it also rises an effective way in human side. So we have to consider more carefully from this nanotechnology. So there are a number of privacy and surveillances because the sensors and devices can able to fix in a tiny room. Each and every watch break we can able to fix this sensors and devices. So it will monitors and it will respond rapidly and it also possesses an individual privacy which is required for robust ethical guidelines. So moving to equitable access. So this nanotechnology will exacerbating socio-economic divides, which is an ethical challengeable key present in this nanotechnology. And responsible development of this nanotechnology is to transparent and collaborative the accountable manner which upholding the ethical principles and public trust. Yes, these are the advantages present in the nanotechnology So in future, the nanotechnology paves the way for freshest mind. So be ready to work in this nanotechnology research centers. Yes, so nanomaterials, which is used to develop a novel nanomaterial with enhanced properties. So nano devices, which is used to design ultra small and highly efficient nano electronic devices. For example, our laptop. In our laptop, there are tiny sensors and devices present, like chip-like structures are present in our laptop. So these kind of chips are silicon-based devices made up of nano devices, nanomaterials. So moving to healthcare, so the nanomedicines also target the drug delivery and treat our body. Yes. So the last question. So need your answers. Yes, can an elephant should stand on a pencil lid? Is it? Can it possible? Is it possible? Can a pencil lid lift the elephant? Yes. Is it? It is possible. So we can able to lift a elephant from a pencil lid through this nanotechnology because the pencil lid has the tip of the pencil lid has a graphene materials, so it is possible. So coming to the conclusion part, so it has a potential ranging from medicines and energy to material science and computing to shaping the future to profound ways. So, moving to the responsible advancement which is present in this nanotechnology, it's used to navigate the ethical and societal implications of nanotechnology, so which will play a crucial role in this external environment, and we can also able to produce or develop innovative ideas from this nanotechnology. So that's all. So any doubts, any queries? Yes, it is possible to lift an elephant because the graphene sheet has the potential to lift huge weight. Yes, any doubts? Hope you understand the nanotechnologies concept. Yes, any doubts? In satellites, in rockets, to purify the ocean water, and also it is used to purify the air pollutions. Is this video useful for you? Thank you for your response. So have a nice day.
I'm grateful to the esteemed delegates of the webinar for their presence and efforts in making this event a great success. I also extend my sincere thanks to our honored resource person and heads of the departments of CSC, IT, EEE, EC, AIDS, AIML, Civil, Mechanical, CSPS, and Cybersecurity. I once again thank Ms. T. Keethna for sparing her valuable time and sharing her knowledge. Thank you so much, ma'am.
Thank you.